All right. Thank you for giving us an opportunity to talk about Pegasus. I'm Karan. I work at Information Sciences Institute in University of Southern California, and I'm here to talk about Pegasus, a workflow management system that sits on top of Condor DAG. So early in the morning, there was a question, what are workflows? Here's our attempt to try and answer that question for you. So scientific workflows conduct a series of computational tasks where the resources can be distributed across the internet. They allow you to chain tasks together, so outputs become inputs, and that replaces manual hands-off. So that enables you to accelerate the creation of your products. Use of workflows provides you ease of use. Depending upon how you share your workflow recipes, there's a potential of giving non-developers access to sophisticated codes. Workflows provide framework to host or assemble community set of applications. There are multidisciplinary workflows that can promote broader collaborations. There are certain rules or guidelines that make it easier to add a code into workflow. So any workflow at its simplest form consists of some workflow building blocks. So you can have a single job that creates one output, or you can have a series of tasks that are generating outputs and then get burst into a single job. Or you can have a job that takes in a large input data set, splits it out into smaller outputs, and those are parallelized for execution. Or it could be a simple pipeline of tasks that get connected together. So using these simple constructs, you can create pretty complicated DAGs or workflows. So why would you want to use Pegasus to handle your workflows? So Pegasus automates complex multiple-stage processing pipelines. We enable parallel and distributed computations. One key feature of Pegasus is that it will automatically execute the data transfers for your workflow. So in your workflow for each job, you will have data dependencies, and Pegasus allows you to Pegasus automatically manages those data transfers for you when your workflow runs, wherever it runs. The workflow description as described in Pegasus is reusable, so that aids in reproducibility. You can use the same description and run it in a different variety of different execution environments. As your workflow runs, Pegasus records provenance about how your workflow is running, where it ran, how the data is produced, and so forth. It handles failures to provide reliability, leveraging retries available in the Condor system. And we also ensure data integrity during workflow execution. One thing to keep in mind, Pegasus is a NSF-funded project since 2001 with close collaboration with the HT Condor team. So both Pegasus and DAG development, we try to have it happen in sync. So some of the success stories in terms of collaborations that are using Pegasus for their workflows. So there's Southern California Earthquake Center, which runs a CyberShake application that tries to build a hazard map of the Southern California region. So these workflows are a mix of MPI and single core jobs, with a mix of CPU, GPU codes. There are large data sets, tens of terabytes, and there can be hundreds of thousands of tasks each in there. So SCIC has been using Pegasus since 2005. So for LIGO, there is a big search group called PyCBC that uses Pegasus exclusively for all their computing needs. And their workloads are more on the high throughput computing side, and they run mainly on the OpenSize grid and the LIGO data grid. So this has been an ongoing collaboration also since the early 2000s. More recently, Xenon 80 also has been using Pegasus for dark matter search, where there's custom data management, and Rusio is being used for some of the workflow data management. Some other applications which we usually don't talk about. So in the past couple of years, USC took delivery of 2 electron microscopes, and along with the USC Computing Services, we built an online system that runs workflows and processes the data as it comes out of the microscopes in real time. So it's an automated system that has been built where, like, as the data is being gathered from the microscope, workflows get launched through Pegasus automatically to do the data processing. And the computations end up happening on the local USC HPC cluster. The jobs, again, are a mix of GPU codes and CPU. Another place where Pegasus is used is there is a large NIMH, which is National Institute of Mental Health Resources. They run a genomics resource, and there that's a big data center where researchers, mainly on the psychiatric side, they are submitting phenotypic data sets for processing. So Pegasus is used to power a web-based system that does curation on those phenotypic data sets that are developed. So there's a web-based system that's powered with Pegasus underneath that allows users to submit their phenotypic data sets, do the curations, and then interact with the results. So before we do any online exercises about Pegasus, I wanted to touch base on some of the Pegasus concepts. So some key concepts to be aware of. So Pegasus consists of mainly 3 parts. So as you know, like, so we have the Pegasus planner, which is this entity that sits on top of Condor Dagman that allows us to translate higher level descriptions of workflows to your execution environment in form of HT Condor DAG. Dagman manages the dependencies and the release of jobs for us. And then HT Condor is used as a broker to interface with different schedulers or submit to Condor itself. Workflows in Pegasus are DAGs, so they're directed acyclic graph of tasks. The notation for representation generally is nodes indicate jobs, edges indicates dependencies. Since workflows are DAG, no while loops or conditional branches are supported out of the box. Jobs, like as Christina mentioned in her tutorial earlier today morning, they are standalone executable. So any job that needs to be executed as part of a workflow, you describe an executable that's associated with the job, the arguments, and so forth. The planning part of the workflow occurs ahead of execution. So what this means, I'll go into more details in the next slide. But essentially, the Pegasus planner takes this high-level description of your workflow and compiles it into an executable workflow for your target execution environment. So one way to think about Pegasus is a workflow compiler. So what do we mean by this? So on the left-hand side, we have a description of how you would describe a workflow to Pegasus, where essentially you talk or you think about a workflow as the order of tasks you want your pipeline to execute. And for each job, you identify the input and output data sets. They are referred by logical file names. So they are platform independent. There are no physical file paths specified when you're describing the workflow. Each job in the workflow or a node is uh, uh, represented as a transformation which maps to an executable on the site where you're going to try and run. So for example, if you're going to try and run bin date as a job in your workflow, you will just have date as the transformation. And then the path where that executable resides, that happens during the planning aspect. So this recipe on the left is just containing what you as the user want to execute, the order in which you want to execute your jobs, and it doesn't have any notion about data movement or platform specific things where your jobs will execute. Now this high level description is fed into Pegasus, and Pegasus generates an executable workflow in form of a HT Condor Dagman workflow, and it annotates this workflow with additional jobs. And during the planning process, Pegasus will figure out where are the inputs located, and it will add data staging nodes to bring in the data for your workflow. As your jobs execute, outputs need to be staged out to a server or a site of your choosing, and there'll be data stage out jobs that are added to the workflow which perform that function. There are registration jobs that get added that will that will register the outputs that are being created as part of the workflow into a data catalog. And Pegasus also ends up adding data cleanup nodes that clean up data that is no longer required by the workflow. So this is a very powerful feature of Pegasus, which is heavily used by our users, especially when running extremely large workflows with large data footprints. So what does a Pegasus deployment look like? So on the left, we have a workflow submit nodes. So this is where Pegasus and Condor get installed. By Condor, I mean Condor Dangman and Condor Sketty. From a user's perspective, they want to run their workflows on a compute site, which maps to a cluster, a Condor pool, and so forth. So there can be one or more compute sites in your setup. The compute sites can map to Open Science Grid, or they can map to a cloud resource or your local HPC clusters. As far as data goes, your data does not have to be available on the submit host. It can be on servers which are remote to the submit host. So those we refer to as input data sites, which host the input data for your workflow. And then there is a data staging site, which is an intermediary data staging server that is used for coordinating movement of the workflow. As your workflow runs, there's an output site where you want the outputs to be placed. And depending upon how you're going to set up your workflows, you can co-locate all three. So you can co-locate your input data site, data staging site, output site with your workflow submit node, or with your compute site. So this is the most general model. And then depending on your setup, these can be co-located. So from a user's perspective, what they say to Pegasus is, here is a workflow that I want to run. My inputs are available on these input data sites. I want the workflow to execute on these compute resources and then bring back the outputs to this particular location. And as jobs launched by Pegasus run, they are annotated at runtime with additional logic that allows the job to pull in the data that it requires. But all this is automated. So as a user, you don't have to worry about any of the data movement part. So there is a lot of data management happening, and for this, we end up using Pegasus Transfer, which is the internal data transfer tool with support for a number of different protocols. So using Pegasus Transfer, we end up creating directories. We end up removing files that are no longer required for the workflow. It does two-stage transfers. For example, your input data sets could be on grid FTP, and then your intermediary data staging server is an S3. So Pegasus Transfer will automatically do a two-stage transfer, will pull down your data set from grid FTP to local file and then push it to a S3 bucket. It does transfers in parallels. It has automatic retries inbuilt. There's credential management, and we support a wide variety of protocols, pretty much everything which OSG supports or what you would need. And it's pretty straightforward to add support for a new transfer protocol in Pegasus. Pegasus also actually comes with the web dashboard, which we won't go in much detail during the hands-on exercises part, but it's a Flask-based dashboard that users can run up, and that allows you to monitor all your workflows. So on the home page for that dashboard, a user sees all the workflows that they are running or have run through Pegasus. The dashboard is color-coded with blue indicating workflows are still running, red indicates failure, and green indicates success. And the web dashboard has a drill down functionality. So you click on a workflow, you'll get more details about the workflow, where it's being run, what directory it's being run on. You can access statistics about your workflow run and see all the jobs, succeeded jobs, failed jobs, drill down to failed jobs, and do your debugging. The same information is also available to the user via the command line through a set of Pegasus tools, command line tools such as Pegasus Status, Pegasus Analyzer, which allows you to debug your workflow, Pegasus Statistics, which generates statistics for your workflow. All these are getting information from a single data source, which is usually a SQLite database in your workflow submit directory. So you're running workflows in a distributed environment. Failures are bound to happen. We have talked about failures in the previous tutorials. So Pegasus leverages everything which Condor Dagman offers in terms of, we set automatic job retries for failures. We have postscripts associated with the job to mine the provenance information. Pegasus handles checkpoint files, and if the workflow fails, rescue DAG gets generated by Condor Dagman, and Pegasus allows you to submit this rescue again to restart your computations. Some new developments in Pegasus, which not many people here may be aware of. Pegasus is also part of the Access support strategy. Access is the successor for Exceed. So Pegasus is used there as a tier 1 tool along with Open on Demand. We have set up a central Open on Demand instance with Pegasus, Condor, and Jupyter that allows users to run HTC workflows across Access sites. So in the support pyramid, we are tier 1, where the idea is like new users can go to the Access website and get started with workflows themselves, or they can also request help as part of Match Plus or Match Premier. So this Access Pegasus node, which has been set up, it allows users to run workflows across Access resources. There's an Open on Demand portal setup that has everything you need with Jupyter notebooks, Access authentication, Pegasus workflow management, and Condor for job management. So one thing which Access Pegasus is heavily using is HT Condor Addicts, which allows users to provision resources from these access resources and create a virtual condor pool dynamically. So if you want to know more about Access Pegasus, you can go to access.pegasus.isi.edu. So at this point, we will switch gears and I'll try and do some hands-on exercises. And if there are any questions, I'm happy to take some questions right now, or we can do them at the end.
Thank you so much, Karan, for the lovely introduction. I'm asking this question as terms of like RCF point of view. At what stage we convey to the user that Tagman is not enough, you need to move to Pegasus? Is there any rule of thumb?
Yeah, so from my Pegasus hat on, I would say always. And the reason why is like, so when we talk to new users, we also say that, even if you have a single job to submit, you should submit it as a workflow. The thing is, once you go down a particular route and then you have to abstract things out, you're probably making your life more difficult. If you were to run large-scale DAGs with lots of jobs, or you were to run workflows in a distributed environment where there's a lot of data management that needs to happen, I would recommend that you use Pegasus out of the box instead of trying to encode that logic in your DAG with submission layer yourself. But that's my personal perspective.
Thank you, Karan.
I'm in a room full of people where they might disagree. All right, so, before we do the hands-on exercises, I hope at least some of you have claimed some tutorial instances. And these hands-on exercises are completely self-guided. There is content written in there. So, you don't need me as a presenter describing Pegasus there. They are meant for users to start on their own and walk through all the concepts. I will do a walkthrough of this. So we talked about this. So I mentioned like what Pegasus does is it takes this abstract workflow and generates an executable workflow. So as part of our hands-on exercises here today, we are going to take a simple diamond workflow, a diamond DAG, where like we have a pre-processed job that takes an input file, generates two output. There are two fine rate jobs that consume those outputs, generate some output that is then added, fed into a analyzed job that generates the final output. So it's a canonical workflow that we use for our training purposes. Yeah, since I couldn't do it on, I guess I'll do this slide. So so one thing which we haven't touched about, which we will in the thing is, so there's an abstract workflow, and an executable workflow gets generated as part of Dagman. In your abstract workflow, you are referring to data and your executables by logical identifiers. So there are no paths specified. So when Pegasus works on an abstract workflow, it needs to consult some catalogs to figure out where your input data sets reside. So Pegasus will consult a replica catalog. We'll go through the details in the hands-on exercises. So the replica catalog just has a simple mapping on where the input files required by the workflow located. Transformation catalog is a similar catalog that is used to describe your transformations or the executables. So whether your executables exist on your target execution resource or they need to be staged by Pegasus. And then lastly, there's a site catalog that describes your computation resources to Pegasus. And by that, I mean, it tells us what directories to use for data staging, what servers to use to stage data to a compute site. Okay, so now I'm going to switch my screen sharing a bit to, all right. Okay, so at this notebook, so I see like people have signed up, and I'm signed up on link 2. I'll click, and it will bring me to the login page. The password is Pegasus23. And this brings us to a series of notebooks that describes the whole Pegasus tutorial. For this presentation, I'm planning to go through the first 3 notebooks. That will give you a good flavor of Pegasus, how the users interface with Pegasus. So, we'll open the first notebook, the introduction chapter. So as I mentioned, it's a self-guided tutorial. So we've already covered some parts of it since I've been presenting, but there's a 5-minute Pegasus introduction which users can go through. This whole tutorial is being run in a Docker container. So there's some notes about how that Docker container is set up, the workflow which we will try and run, the catalogs and the function of them. Now, to run the workflows through Pegasus, we are going to use Python 3 workflow API that Pegasus provides to the users. So this was introduced in Python in Pegasus 5.0 release, and it's fully documented in the Pegasus reference guide. But a high-level overview of the components, so you can import all the catalogs, the workflow objects, the job objects, and so forth. Or what we will do in this exercise is we'll just import everything from Pegasus.api. So now it's always good when doing your Python stuff to configure logging. It's optional, but we recommend it. So we're just setting the we're importing the logging module, and we are setting the debug level to the logging level to debug. And then, we will configure Pegasus properties. So Pegasus properties are a way to control or configure Pegasus. By default, you don't need to configure anything. And in this case, we just have some sample properties specified, which are for monitoring or reporting purposes, but nothing. So we're just going to run Pegasus in the default configuration. So through properties, you can associate, Condor class adds values with jobs and so forth. And on the properties object, you can also do a listing saying, okay, tell me all the properties which start with Condor.request, for example. So now we'll create a replica catalog, which is, and any initial input that is required for the workflow has to be specified in the replica catalog. So we refer to those as raw inputs, like an input, a file for the workflow that is not generated by any job in the workflow. So in this example, we are just going to create a simple text file in our current directory. So we open a file f.a, and we just say, these are the contents of the input for the diamond workflow. So this file will be used for the workflow. And how do we describe to Pegasus that, where this file resides? So what we will do is we'll create a file object, fa, say that the logical identifier for the file is f.a, We can add certain metadata to associate with the job. And then we'll just create a replica catalog object. And we'll add a replica where we'll say that the file resides locally. The logical identifier is FA, and it resides in the current working directory, and we'll write it out. And if I cat the generated replica catalog file, it's a simple YAML formatted file, which is saying that there are replicas. There's a file FA, which is available on this location. So a particular file can be available at multiple data servers, and then Pegasus will do replica selection and try and pick the best replica to stage. But in this example, we are just specifying one location. Similarly, we're going to next create a transformation catalog, which will describe what executables are being invoked by the jobs in the workflow. So it's similar to the replica catalog. So we'll say, so we have a transformation called pre-process. It resides on site condor pool. On the site condor pool, it's available at this location. Is stageable is false, that the executable is installed. You can set this flag to true, and then Pegasus will stage your executables also in addition to your data. We specify the architecture for which this transformation is compiled for, and the OS. So in our diamond workflow, we have 3 types of job: pre-process, find range, analyze. All the 3 types of jobs, they map to the same executable Pegasus keg, which is our training executable. So we'll do the same thing. We'll create a transformation catalog object, add the transformations, and write it out. And it's similar to the replica catalog, but it's talking about your executables or your jobs invoke. So so it gets written out in a YAML format. And then, we are going to try and create the workflow that we want to try and run. So the workflow object in Pegasus will be used to store the jobs and dependencies between each job. Typical job creation, as Christina also mentioned in her tutorial, you describe what are the inputs, what are the outputs, what are the arguments with which a job needs to be invoked. So we'll create some input variables, output variables, add the arguments, any profiles or environment variables that need to be associated with the job, and then add the job to the workflow object. So in this case, now we are going to create a workflow. So we'll say a workflow, give it a name, black diamond. So we already defined file FA when we were creating the replica catalog. So we are creating file FB1 and FB2, which are the outputs that are generated by the pre-process job. So we say job pre-process, we add the arguments. So the arguments with which that executable needs to be invoked with. We associate the inputs and outputs for the job. And then, we do it for all the 4 jobs, and then add the jobs back to the workflow object. We can write it out and then try and visualize it. And it will show you that, we're just creating a simple diamond of a workflow. Now, what we are going to do is run the workflow. And as part of running the workflow, we will invoke the plan command on the workflow object. We are going to give a submit flag, which says that submit the workflow for execution, and then we'll just wait for it to finish. So what this does is it plans the workflow, And at this point, we've submitted it, the underlying Condor DAG for execution. And when your workflow gets submitted, like if you're going on it through the command line, it will tell you what directory your workflow is running from, how to monitor the workflow. You can run the Pegasus status command. If you want to remove your workflow, you can do Pegasus remove on the workflow submit directory. So this workflow will take a minute or two to run. And we provide the progress bar, so it's showing you how the workflow is running. How many jobs have completed, if there are any failures, or the jobs queued. Yeah.
So I have a couple questions while we're waiting for this to run. So first, in the transformations mapping, it looks like each node in the workflow can only correspond to one type of resource. Like you can't say I have this node that could run here, here, or here, or is that possible?
Yeah, it's possible. You
Okay.
In your transformation, you'll specify.
Oh, you specify multiple
Yeah.
resources. Okay, that makes sense. And then I had a question from the beginning, actually, the properties piece, because like the Condor request attributes aren't in that YAML file. Are they being are they being loaded through the link that's there?
So those I was trying to demonstrate that these are the Condor properties that Pegasus is aware of. So it's sort of like for users to say, okay, what type of Condor request properties are there?
So that's just like you load Pegasus and it's aware of Condor and it can just print that. Got it.
But
okay.
In this tutorial, we have not associated those profiles or properties with the jobs. So that's why, like when when we were describing the job, we didn't say add profile and say request CPU or request GPUs.
Okay, great, thank you. Oh, wait, sorry, one more question. So the input, the file catalog.
Yeah.
Wait, so you said for input files, so that really means like the very first input files in the workflow.
Yes.
If something is an output that becomes an input, that's going to be managed by the workflow.
Managed by Pegasus.
And it doesn't go in the catalog.
Yeah.
Okay.
So it's just for the raw inputs.
We had one more quick question on Zoom here. Question is, how can we see the monitoring dashboard while the job is running?
Yeah, so through the Jupyter Notebook, unfortunately, like we don't have the dashboard started up since we are running everything in a container also. But if you install Pegasus at your end, there's a command called Pegasus service that will start the Flask server, which will bring up the dashboard. But so as I mentioned, like the dashboard, all the command line tools, they're getting information from the same SQLite database. So I see like my workflow has completed. Now, if I want to generate some statistics about my workflow, I can issue the statistics function on the workflow object. And that will tell me, how many tasks. So tasks are like how many jobs you defined in your input workflow. So we were running a diamond workflow. So there are 4 tasks in it. So all of them succeeded. There are 17 jobs in all because Pegasus added some data staging jobs, some cleanup jobs, and so forth. Those succeeded. There are no sub workflows, like we didn't try to run a hierarchical workflow. It tells you the workflow wall time, which is like from a user's perspective, how long did it take for your workflow to finish? So in this case, it's around 3 minutes. Then there's a cumulative job wall time, which is just the sum of the execution time of all the jobs in the workflow. So that's about 60 seconds. as seen from submit side, that's the Dagman view. And then we also report some integrity metrics about whether there was any integrity errors that happened during data transfers. So it says, there were 10 files that were checksum, and there were 6 files whose checksums were generated. So those are the intermediate data files. So I hope everybody was able to run this first notebook. And sorry, I'm not monitoring Zoom chat, so I'll take the questions in the Zoom chat at the end. So now we can, go back and go to the debugging chapter. So this notebook gives you a flavor of, what additional tools Pegasus provides, which can help you with debugging of your workflows, right? So in this case, we're going to run the same workflow again, but what we are going to do first is we're going to make sure that the input file for the workflow, we remove it. So we've removed the raw input file for the workflow. So we run. So we'll do the same thing. So in this case, the whole code is in one cell, and we'll run the workflow. So now, when the data staging happens, you would expect it to fail because we had deleted the file FA from the file system, right? Yeah, so now you see like the workflow status. It says the workflow, there's a failure on the workflow. There's one job that has failed. So what we can do is on the workflow object, I submitted it again by mistake. Sorry, I always trip on this exercise for some reason. Okay, we just started in another workflow, and let me see. Sorry, I was so in the background. Did Mats correct me? So we do run the dashboard in the training instances. So you can, while this is running, I will just. Right, so while that notebook is running, so Here it's telling me we've run 3 workflows so far. Both have failed. So if I do one of my successful workflows, it will tell me what's the name of the workflow, submit host, what user the workflow is running in, what's the submit directory. And then, I can go through all the jobs in the workflow, pick up a job, and then it will tell me, what directory the job ran in, what are the output .out.er for the file, what type of job it is, what site it ran on, what host it ran on, job states, and then, we'll show you your job invocation. So we'll tell you how that job executed, what was the executable that ran, what was the duration, any metadata associated with the job. Okay, so this workflow was failed. So if I run the analyze function on the workflow, it will show me what, again, a breakdown of the total jobs in the workflow, which job failed. And for the failed job, it will give me information about where that job executed, how it was executed, what were the arguments, what was the working dir, and the std out for the job. And there, as you can see, it says the expected local file doesn't exist, the source. So this is the output from Pegasus Transfer, which shows me involved. But think about, like, you're running your workflow, your executables, it will show you what the reason with which, or the error message with which your jobs failed. So now let's try and resolve that issue. So we'll move the file back. And now what we'll do is we'll restart the workflow. So when we now run the workflow again, it will end up submitting the rescue tag below. So instead of the plan command, you will notice we've done a run command. So a run function on the workflow object. So what that does is it takes in the rescue tag that's, or whatever, if there's no rescue tag, then the DAG file in that submit directory and submit it for execution. So it will restart from where it failed, and hopefully now this workflow should complete. Yeah, so while this workflow should complete, and I'll since I'm running out of time, I'll quickly give a walkthrough of the third exercise, which is very similar to the first exercise. It's just giving a flavor of the command line tools. So they're like, we are a Linux community. If you want to interface using the command line, the tools. So what we'll do is we'll generate the workflow. And then, so the workflow gets generated using the Python API. And then we can open a terminal and submit the workflow for execution using the command line tools. So let's try and do that. So I just opened the terminal. Right, so we have this YAML file. We can use the Pegasus plan. We'll just give the submit option to and you'll see similar outputs for and then it tells us. So Pegasus tries to number the directories for your workflow submit does, and then this workflow submit directory is used as input for all the subsequent Pegasus commands other than the Pegasus plan. So I can do Pegasus status -L and get a status of the workflow, what job is running. If I want to remove a workflow, I can run the Pegasus remove command, so that will remove the running workflow. And I can add -W to watch. So this exercise is just highlighting how we are doing it on the command line, what we were doing earlier all throughout with the Python API. And once the workflow completes, we can run the Pegasus statistics command to generate the statistics for the workflow. Since we are almost out of time and I want to leave time for questions, I am going to switch. Yeah, so I hope you got a good flavor about Pegasus, describing workflows in Pegasus and running. So these training accounts will be active throughout the week. More information about Pegasus is on Pegasus website. We have a users mailing list. If you did for support, you can ask for support using our user Slack or send email to pegasussupport@isi.edu. There's a YouTube channel for Pegasus where Pegasus talks appear. And at this moment, I'm happy to take any questions.